Hello, everyone. So welcome to Theo-MathProblemSolver. In this very episode, we are going to stress on the applications of maximum minimum principles. In our previous episode, we are looking at the maximum minimum principle 1 and 2. And we you know, look at certain theorems that would enable us to solve problems. But in this particular section, we are going to, use those theorems that relates to principle 1 and principle 2 to solve real world, problems. I would want to point out that mathematics play a very key role as far as problems in this world is concerned. Okay, so I just want you to kind of take note that the problems we are being confronted with in this world can be, most of them can be solved. Apart from the spiritual aspect, most of all the physical aspect can be solved using mathematics. So please stay tuned, and at this point, if you have not you know subscribed to my channel, please do so. Comment, liked, and share this content with your colleagues and loved ones. And let's keep spreading the good news that we have as well. All right, so let's get started. So I want us to look at the first problem of the day. It says that from a thin piece of cardboard, 8 inches by, which is measured 8 inches by 8 inches, square corners are cut off so that the sides can be folded to make a box. Okay. So let me underline some key things here. So we have a cardboard that measured 8 inches by 8 inches, and it is said that square corners are cut off so that the side can be folded to make a box. So let me underline those keywords. Now, the question says that what dimensions would yield a box of maximum value? What dimensions would will yield a box of maximum value, and that what is the maximum value? Okay, so once we are talking about cardboard, so it means that we have to draw the cardboard and see how what best or the next thing to do. And so the first thing to do is that let's draw the cardboard. So suppose this is our cardboard that we have drawn, and but the question to say that the cardboard is measured 8 inches by 8 inches. Is that okay? Good. It says that it's measured 8 inches by 8 inches. So we have that. And it's also said that square corners are cut off so each corner, so we see that the corners have been cut off. So the first corner here, we cut off here. Okay. So the square corners are being cut off. So this is the corners you're talking about. We also cut this side as well. Okay. We also cut these corners. We also cut this side or this corner as well. Is that okay? So that is what we are trying to talk about. And it is said that after they are being cut off, they are being folded to make a box. So, and that translates into we having this, box. Okay. Now, I want to say that for us to move from this cupboard to this box over here, what we are going to do is that, remember, each corner has been cut off. And remember, the full length on either side is 8 inches. So if each corner has been cut off, it just means that there has been a reduction in the length. Is that okay? So it means that, and that is why we have this. That's why we have 8 minus 2x. Because if each side or if each corner has been cut off, each corner of this cardboard has been cut off, it means that two things have been taken off. Is that okay? So that's why we are going to have 8 minus 2x. And remember, we said that x, let me use a different pencil here. Remember that we said that x is the length of each square to be cut. Okay. So we said that x is the length of each square that it needs to be cut. If that's the case, then we're going to the full length that will be left to be 8 minus 2x. Is that okay? Good, good. So Now I believe that somebody may be wondering why we have x over here. Remember that remember that if you are doing the cutting, what is going to happen is that, okay, let me do a quick illustration. I don't know if you'll be able to draw this, but let's try this. Okay. Okay, let me use a different pencil to see how best I can help you to understand this. All right. So we see that the length of the length of this cupboard is 8 inches, right? And remember, it was said that square corners are cut off. Okay, square corners are cut off, and remember that x is your length of each square. So what it means is that if each corner is being cut off, it just means that one length would just be 8 minus. So in that case, one length of the cupboard will just be going to be 8 minus 2x. Remember, because each side of the length has got two sides being cut off. So the remaining one will just be 8 minus 2x, right? And the other side will also be that. But then if you try to fold it, you would realize that you will only have one length of which what we said that one length of each square is x. Okay. And that is why you're going to have the height to be x. Do we all get it? Okay, good, good, good. So we're going to have only the height to be x. So on that note, we can now, since we are talking of a box, it means that what comes to mind would be what? Would be volume. And the question was also very much specific. It says that we should say that what dimensions would yield a box of maximum value of maximum volume. So what's the volume? So let me say this, that so solution. Now, what is a volume? What would be the volume of a box? What is the volume of a box? Anyone? So the formula for the volume of a box is what? It is length times what? Length times what? Let me use this is length times what? Width times what? Times height. So we are going to have this length, this width, and then the height. Is that okay? So good. Now what is the length? The length is what? 8 minus 2x. And then the width is also what? 8 minus 2x. And then the height is x. So let's try and probably maybe expand it just to make it easy, right? So when we expand, so let's use v of x to represent the volume, okay? So we are going to use v as a function of the dimensions, okay? Good. Now, when we expand and simplify, I think we should have 4x to the power 3, 32x squared plus 64x. Is that okay? Over here, I want us to note that x must be between 0 and 4. Is that okay? X must be between 0 and 4. And the reason is simple over here. Because if remember that the highest length, or probably the maximum length that this probably, or this length, or the length on the width can attain is what? Who can give us an idea of the length, or the highest length that it can assume? Over here, it is not easy to see that, right? So what it means is that, for example, this is what I want us to look at it, because look at this. If the length, let's do some illustration here. Let's say, so remember your length is 8 minus 2x, okay? So if, for example, if the x is 4. So you see that when x is 4, we are going to have what? 8 minus 8, which is 0. So which means that the length can never be 0, because if the length is 4, the length can never be 4. Sorry, x value can never be 4, because if it is 4, it means that the length will be 0, right? Of which, in that case, we don't have anything at all. If the length is 0, it means you don't have anything at all. And the same applies to the width, right? If the width is also 0, then it just means that you don't have any box at all. Okay, so we have to make sure that x values would just be within 0 and 4. Okay, x values should always be within 0 and 4. Because if there's 4, it just means that we don't have any length and we don't have any width as well. Is that okay? Of which we don't want that. So we have to ensure that x values should be between 0 and 4. Is that okay? Very good. Very good. Good, good, good. All right, so let's see what we can do. So it just means that we need to maximize the volume, within the interval 0 and 4. Okay, so let me write something here. So we need to maximize the volume over 0 and 4. Okay, good, good, good. So let's take note of that. Very important, please. It is so important. Now, the first thing to do is to find the first derivative. Okay, so what will be the first derivative? So the first derivative of this function of this volume will be what? So the v prime of x should be what? That should be 12x to the power 2 minus what? Minus 64x plus what? 64. Is that okay? Now the B part, what we need to do is to find the critical values, right? So find the critical values. So this implies that my V prime of x should be equal to 0. On that note, we should have 12x squared minus 64x plus 64 equal to 0. So what we can divide both sides by what? By what? By 4. And by dividing both sides by 4, or each term by 4, you should have something as this. Is that okay? Then when you factorize, you should have 3x minus 4, x minus 4 equal to 0. So on that note, we're going to have x equal to what? 4 on 3, or x equal to what? 4. Now, so we need to pay attention over here because of what we kind of talked about earlier on. Now we have two critical values. Now, are these critical values within the range of 0 and 4? Are they within? We saw that it is, you see, it is very obvious here that x equal to 4 cannot be within this open interval 0 to 4, right? X equals 4 cannot be within this particular interval. So on that note, we are going to disregard, okay? So you're going to disregard this particular value, okay? So we are just going to concentrate on 4 on 3, because 4 on 3 is the only value that can fall within 0 and 4. So please, let's take note of that. Is that okay? And over here, I also explained that the reason why we need to create a condition on the volume is because if x is 4, it just means that we are not going to have the length and the width. Is that okay? We are not going to have the length and the width. In that case, we're going to have 0, 0. Okay. If x is 0, if x is 4, it just means that we are not going to have the length and the width. We would have 0, 0, of which we don't want that, right? So it just means that we need to create a condition for the length and the width. Okay, so let's take note of that. Very, very important. All right, so in that case, we are going to rely. So the only critical, so I will say that the only, let me write it. So the only critical value will be x equal to 4 on 3. Is that okay? Now, since we have exactly one critical value, we are going to use principle 2, right? Principle 2, we only use principle 2 when we have only one critical value, okay, within an open interval. Is it okay? Very good. So let's take note of that. So with principle 2, it just means that we're going to have the second derivative, right? So with the principle 2, we kind of find the the second derivative. And what will be the second derivative? Remember, the first derivative is this. So the second derivative will have what? So we are using this. So the second derivative will be what? Second derivative will be 24x minus what? 64. Very good. And we said that we are going to evaluate this second derivative at the critical value, right? So we are going to evaluate that at a critical value, which is 4 out of 3. So on that note, you're going to have, and that should give us what? And that should be, will it be positive or negative? That should be what? Less than what? Less than 0. So if it's less than 0, what can we say? Would we talk about minimum or maximum? If it's less than 0, we said that we'll be talking about what? The maximum. Is that okay? So um but then remember, we also said that we have to evaluate the main function or the main volume at the critical value, okay? So we also have to do that. So let's evaluate the main function at the critical value. And what is the main function? The main function v of x was given as what? 4x to the power of 3 minus 32x squared plus 64x. Is that okay? This was the main function. So now we are going to evaluate that. So by evaluating that, at that function, we should have for multiplying 4 out of 3 to the power 3 minus 32, multiplying 3 out of that to the power this plus 64, 4 out of 3. Is that okay? And when we do that, we should have, if you use a calculator, you should have 37 or number 25 out of 27 inches, since you're using inches, the or the length you're looking was in inches. Okay. Okay. So which means that the volume, the maximum volume. So this means that the maximum volume will be this. So this means that, let me use a different pencil rather for this. So this means that the maximum value will be this. Okay. And where will it occur? And it will occur at where? And it will okay, at what x equal to what 4 out of 3. So it just means that for us to have such a volume of 37 whole number 25 out of 7 inches, we would need a length of what 4 out of 3. Is that okay? So I just want us to appreciate that. I believe that this is now close to home. Now you are more, getting it, and we'll solve one or two more examples so that for you to be able to understand it better. Okay, so stay with me. And at this point, if you have not subscribed, please do so. Like, comment, and share my content with your colleagues, loved ones, and let's help, demystify the myth around mathematics. I want to point out that there are quite a number of people who are struggling, and the only way by which we can help them is to share this content with them. Okay, and as always, we give the best tutorials, we give the best content. So please, let's help spread this good news. All right. All right, so let's look at the second example for the night. And so with this second episode, we are given a stereo manufacturer who wants to determine it in order to sell X unit of a new stereo. Now the price per unit in dollars must be this. Okay, so we are given the price in a form of a function. So the price is given in a form of a function. Now, the manufacturer also determines that the total cost of producing X unit is given by this. So the total cost is this, and then the profit is that. So how do we use this information to solve our problems? Now, solution. So if I were you, probably I may want to pause the video and try to see whether I'll be able to solve it on my own. Now, the first problem says that the first problem says that it says that find the total revenue, RX. What is revenue? What is revenue? What is revenue? So revenue is always what? Quantity times what? Times price. Okay. Revenue is always quantity times price. Is that okay? Now, per the question, what is our quantity? Remember, the question says that the manufacturer wants to sell what X unit of new hot stereo. Okay, so X unit. So the quantity is what X unit. Is that okay? And then the price is already given. But then we also know that the revenue is always what quantity times what times price. Is that okay? Good. So with that, we should have, the quantity is X, and then the price is given. So in the price, it was given as what 100 minus X. Is that okay? So this is your revenue. So your revenue is in this function form. Is that okay? Now the big part is that we want to find the total profit. The total profit we represent as a P of X as a function. Now, what's our total profit? If I have revenue and I have the cost, that will then become the profit. So the profit will just be what total revenue minus what total cost. Is that okay? Good. Now, what is our total revenue? Total revenue is what? We have already solved that. And that is here, our total revenue, we said that is what? 100x minus x squared minus cost, total cost. The total cost was given to us as this. So which is what? 3,000 plus 2x. Now, when we expand and simplify, we should have what? We should have minus x squared plus 980x minus 3,000. Is that okay? Very, very important. Good, 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 good. All right. Now the question says that the the question went further to ask that so that's the C. How many units must the company produce and sell in order to maximize profit? So since we want to maximize profit, it just means that we can't leverage, okay? We can't leverage the theorem on the maximum minimum principle one and principle two. And so with that, it means we have to find we have to find the what? We have to, so let's see. So the I part, we have to find the first derivative of the profit. Now, what is the first derivative of the profit? So the first derivative of the profit will just be what? Minus 2x plus what? 980. Okay. Now, since so in the II, we need to find the I pi. We need to find a critical point as which this we can obtain the profit. So we need to find a critical point. Okay. Then the critical point. How do we do that? So we need to find the critical point. So with critical point, we set the first derivative to 0, which implies that minus 2x plus 980 should be 0. In which case, we're going to have x to be what? To be 490, right? So since there is only one critical value, we can use the second derivative to determine whether or not it yields a maximum minimum, right? Because that's what the maximum minimum principle two state. It states that if you have only one critical value, we have to use that theorem. Is that okay? Good. So on that note, we will have to go on to find the second derivative. Now, what will be the second derivative? So the second derivative of the first derivative will be what? Will be just be minus 2. Then the third thing is that we evaluate this second derivative. We evaluate it that way at the critical value, which is what? 490, which will still give us what? -2, right? Good, good. Now, the final thing we need to do is to evaluate the main function at the critical value. Now, what is the main function? So with the main function, our main function is this, is our main function, which is p of x equal to minus x squared plus 980x minus 3000, right? Good, good, good. So we need to also kind of evaluate it at the critical value, and which is that p prime of x being evaluated at x equal to 490 equal to what? So in which case we should wherever you see x in that, we should replace it by 490, right? So negative that to the power 2 plus 900 multiplying 490 minus 3000, which should give us what? What did we get? That should give us what? That should, I think when you use the calculator, you should get like, since we are using dollars, so let me be more specific. So you should get 237,100. Okay, good. Now it just means that the manufacturer makes a maximum profit of this when for 490 units are bought and sold. Is that okay? Very, very, very important. Good, 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 good. So let's move on to the next question. The next question says that the next question was asking that so what is the maximum profit? So the maximum profit, already we have done that. The maximum profit is what? So the maximum profit So the maximum profit is what? Is this particular value, okay? So our maximum profit is this particular value. All right. And that let me see the last question of the it says that what price per unit must be charged in order to make the maximum profit. So that's the E part. So the E part, so the unit, so it just means that we need what X what 490. So we have to so just means that 490 units are to be bought and then sold in order for us to make such a profit. Is that okay? Very, very, very important. So at this point, I believe we've been able to embrace the principle two, which is the maximum minimum principle two, which state that if it does so happen that we have a function, a continuous function that is differentiable over an open interval, it, it and it just so happened that it has one, critical value, then we can use that particular theorem. And having seen that, we have to go further to find the second derivative of that given function and then evaluate that critical value. And after that, that would give an idea of what is a maximum or minimum. Now, having done that, you have to go back to the main function and evaluate it at the critical value. And that will be the end of that. All right, so I believe at this point we are now okay. And once again, if you have not subscribed, please do so. Click on the notification button, like my content, comment, and let's help spread this quality content. Thank you so much. So let's move to the last content of or the last example of the day. Now we are moving into biology, chemistry as well. So very, very, very important. Let's take note. All right. Now we are in the life sciences. Now we are going to look at the concentration of a drug in the bloodstream. Now, a drug is administered into the bloodstream, Now, let this function represent the concentration, okay, which is denoted as C of T in nanograms per milliliter, okay? Good. Which is that, okay, the unit is that, and of the drug, T minutes after it is administered. Now, the question is, what is the peak concentration? What is the peak concentration of the drug in the bloodstream? And when does this peak occur? Very, very important question. And I would want to point out that these are areas that usually I like to test my student on. And so if you're one of my students, I want to take note of this particular problem because it's interesting because it's a real world situation. And the question is, when we are given such problem, how do we attempt them? How do we leverage the theorems, the concepts, the definitions we've learned so far to solve problems like that? So stay with me even as we get it started. And if you have not subscribed, please do so. If you have not liked my content, please do so. Comment as well. Share the content to your colleagues, to your loved ones, and let's help demystify the myth around mathematics. Some people think that mathematics is only for the geniuses. Mathematics, some also say that mathematics is not creative. No, mathematics is not only for geniuses. Everybody can do mathematics. Mathematics is creative. The more you practice, the more you become good at it. And the more you teach others, the more you master the concept. And with that, you'll be a master of your own. Right? Good. So let's continue to embrace this quality content. And as I mentioned, help spread it, share it to your colleagues, loved ones. If you have not subscribed, if you have not liked, if you have not commented, if you've not done well at all. So please, let's keep the message spreading. Okay. All right. So let's get started. All right. So we are given the function or the concentration as, so the concentration, so before I start, probably you may want to try it on your own. So please pause the video and try it on your own. Let's see. All right. So let's get started. So we are given the concentration as 25T multiplying e to the power minus 0.04t. All right. Now, what is the peak concentration of the drug in the bloodstream? I would want to point out that also in the pharmaceutical industry, such principles, theorems are being applied over there. You know, before I will say that before a drug is being manufactured, it has to go through a lot of transitions, and one of the stages is that mathematician would have to come on board to help, develop models, mathematical models to understand how this particular drug can be administered and what time. And that is why when you buy any drug, if you read the labels, it gives you the product which can take the drug, and all of these things were done by mathematicians. So mathematicians are, even though you may not see us outside, but behind the scene, this vaccine and all of that, it is we mathematicians that produce them. We work alongside the physicians. We work alongside the pharmacologists to come out with this stuff. So please, let's respect mathematicians, because we are playing a very key role in our society. We don't come out to talk about, but behind the scene in the banking industry, mathematicians, we are working so high. Now we have with this AI, with the emergence of this AI, the mathematicians, we are working behind the scene to make sure that the AI algorithms are working so hard, like the likes of ChatGPT and all of that. We mathematicians, we are testing their models to make sure that their algorithms are working so hard. So please, let's respect mathematicians, because we deserve to be respected and to be given a platform to speak what needs to be said. All right, so let's get started. All right, so now what is the peak concentration of the drug? The peak in this case is what? The maximum volume, the maximum concentration. Okay, so the peak concentration means, peak concentration can also mean what? Maximum what? Volume, okay, or the maximum concentration, or the maximum how do I put it? The maximum number of drugs that is in the bloodstream. Okay, very good. Now, what's the first thing to do? Let's go straight to the point. What's the first thing to do? Now we need to find the first derivative, right? Now we need to find the first derivative. Now this is a product function. This is a product of two functions, right? This is a product of two functions. So with a product of two functions, we use a trick. So we cover one function, then we differentiate the other, then we do the same for the other. Is that okay? So the first thing to do, let's try and cover the first function. So let's first cover this particular function. Let's cover this. So let's cover this function first. So by covering it, we are going to differentiate the other. So we're going to cover this. So we're going to have 25t. Then we differentiate e to the power minus 0.04t. Then we're now going to cover, cover this one. So by covering that, it just means that we are going to keep it outside, minus 0.04t, and then differentiate the 25t. Is that okay? Good, good, good. All right. Now, when we differentiate this, what do we get? What do we get when we differentiate that? So we are going to have what? Negative 0.04 multiplying what? Negative 0.04t. Okay, plus. Now when we differentiate this, what do we get? So we are going to have 25. Then we multiply that by what is outside that. Okay. All right. Now let's try and simplify it a bit. Now by simplifying, we should have 25 multiplying negative 0.04t 1 minus 0.04t. Is that okay? By factorizing. So this come by factorizing. Okay. By factorizing, you have this. Is that okay? Now, what is the next thing to do? Now, the next thing to do is that what the next thing to do is to find the critical values. So find the critical values. Now, how do you find the critical values? We just have to set this, the first derivative to 0. So on that note, we're going to have 25 multiplying e to the power minus 0.04, 1 minus 0.04 t equal to 0. Now, this week we've been kind of looking at uh, instances where we said that the exponential function can never assume 0, right? So it means that this one can never assume 0, but then this can assume 0. Is that okay? So since we want to say that since e to the power negative 0.04 is positive for all t values, then what? If that's the case, we are just going to have 1 minus 0.04 t to be such 0. It's the only thing that can assume 0, okay? On that note, our t should be what? Is that if that's the case, our t has to be what? 25. When you solve for your t, you should have that. So, which means that t equal 25 is the only critical value. And if that's the only critical value, then which of the principles can we use? Is that one? Is that principle 1 or principle 2? That should be principle 2. Very good. That should be principle 2. With the principle 2, it was said that if we only have one critical value, then what? Then we have to go on to use the principle 2, and that we should also ensure that we find the second derivative. Is that okay? The second derivative. So on that case, on that note, we are going to go further to find the second derivative. Now, the second derivative, so find the second derivative, okay? So the second derivative, which means we're going to have c prime prime of t. And that should give us what? So on that note, we are going to differentiate this. Okay, so our first derivative, let me just bring it back so our first derivative was 25 multiplying e to the power minus 0.04 something as this. Is that okay? Good. So this is a product of two functions. So we have one function and another function as well. So we are going to use a product rule to differentiate it. So the second derivative of such function, so the second derivative of such function will be what? Will be so we first keep one function. So we first keep one function and differentiate the other, okay? Then plus we kind of keep this and then differentiate what? Differentiate the other function. Is that okay? So 25. All right, so on that note, we should have something as this. Now, when you differentiate this, we're going to have what? We're going to have minus 0.004 multiplying 25 e to the power 0.4t plus what? So you have 1 minus 0.04t and what? Minus what? Minus e to the power 0.4t, and that in all, when you simplify it a bit, you should be able to have something as what? As let's see, fish out this, and that should give us e to the power point of 0.4t, and that 0.4t minus 2. Is that okay? Good. Now we are going to evaluate this at the critical point. Okay, so we are going to evaluate this at the critical value, and then we saw that the critical value was 25, right? So by evaluating that, we should have what do we have? You should have minus what 1 on e, okay, which is what, which is less than 0. So if it is less than 0, but we are not done, right? We also have to evaluate the main function at that. We also have to evaluate the main function at t equal to 25. And the main function was what? The main function that we're given was 25. Okay, so this was the main function. Let me write it down here. So the main function that we're given per the question was c of t equal to 25t multiplying e to the power minus 0.4t. Now we are going to have 25. It just means wherever I see t, you just replace by 25, okay? So this multiplying that, and that should give us, what? I think if you use a calculator, you should be able to get a final value. I think if you do that, you should get something like 229.92 nanogram per milliliter. Okay. All right. So now we've been able to kind of solve this particular value, this particular problem. So I would say that if I want to draw it, if I want to draw such a if I want to draw the solution of this particular problem, this was our C of t. It just means that this was how high per if this is the if this particular let me underline it well. Since this is a peak concentration, it just means that this was how high it was. This was how high it was because we said it's a peak concentration. So it just means that at some point it kind of increased and got to this point, then it begins to probably decrease. But when you look at, because this was an exponential function, right? And this minus means that to go to a point where it would, this e to the power minus 0.04t just means at some point it would decrease as time increases. So it means that it would increase and attain such a peak. So this was what we were referring to as the concentration, the peak concentration. So the peak concentration, it just means that at this point you're going to have 25 and then the value of what? 229.9. Oh no, let me take my time to write it well. So it just means that at time at time 25, we're going to have 25 here, and then 229.92. And then 229.92 is our peak concentration. Okay, so our peak concentration. So our peak concentration is 229.92. All right. So we've been able to solve this interesting problem, and I believe that we are now okay with this. If you have not subscribed, please once again, let's subscribe. Let's keep sharing this good news, this quality content with our colleagues, with our loved ones, so that we can help demystify the myth around mathematics as well. And as always, I bring you the best content. So please, let's support this channel. Let's promote it and keep spreading it. If you have not subscribed, you have not been sharing it, then you have not done well at all. Thank you so much. And stay blessed. I'll see you in my next episode. Bye-bye.